Once the painting was brought to the studio, our technical examination began by first spending time looking closely at the painting's surface. Visual examination, typically aided by magnification through a microscope, allows us to document many facets of the work. Importantly, museum conservators can look for microscopic evidence of issues that may exist in the painting, for example, areas of loose paint, discoloration, or paint degradation, and begin to address them if any are found. We can also discern the individual paint strokes and begin to appreciate the often complex pigment mixtures present in some of Van Gogh's colors. And we can identify areas of different textures and paint thicknesses. In irises, we find areas of high impasto, where the paint almost looks like you could walk through it as though it formed the walls of a canyon, but also areas that are so thinly painted that you can see the white priming layer and canvas nubs peeking through. By examining the surface and noticing where Van Gogh used different materials and textures, we can begin to formulate a better sense of his overall painting technique and how he manipulated his paints to achieve particular results. We add to our visual examination by utilizing light at wavelengths other than visible light to both examine and image the painting. Each type of light that we use provides unique information about irises beyond what we can see with our eyes. Ultraviolet light, for example, can reveal where now faded pigments once were. Infrared reflectography allows us to see through some of the paint on the canvas, often revealing preparatory layers, while transmitted infrared imaging gives us a sense of how thickly or thinly painted particular passages are. X-radiography images through the paint layers and helps us identify modifications made during painting. We can also use the X-ray image to identify the actual weave of the canvas itself, allowing us to determine the bolt of canvas that it came from and what other Van Gogh paintings were, quite literally, cut from the same cloth. All of these, UV imaging, infrared reflectography, and X-radiography, are forms of technical imaging. We also used our time with irises to perform X-ray fluorescence scanning, or XRF scanning for short, of the overall painting and of specific important details within it. XRF scanning is becoming a common approach in technical analysis because it allows us to map the distribution of the chemical elements present in the painting. From these element distribution maps, combined with our knowledge of what materials were available in 19th century France and what paints Vincent asked his brother Theo to procure for him, we can often infer which pigments were used to create which colors. The technique also allows us to visualize the distribution of multiple chemical elements simultaneously, allowing us to understand how different paints relate to one another. This can help us determine whether the paints are mixed or layered. So we can not only infer which paints Van Gogh used, we can also begin to understand where he chose to use single pigments to create strong, vibrant colors, and where he mixed or layered those paints to create more nuanced shades and tones. With each new piece of data we gathered over these last several months, we found ourselves with new or more specific questions, and the research has expanded and adapted to address them. To complement the XRF scanning data, for example, we used microscopic samples taken from the painting, both to more clearly visualize how the paints were applied and so that we could apply a powerful molecular spectroscopy, called Raman spectroscopy, to confirm the identity of the pigments present. We've used techniques like fiber optic reflectance spectroscopy and gas chromatography mass spectrometry to help us better understand the organic components of the paints, since these can't be easily identified by Raman or XRF. When we gathered evidence that suggests color change may have occurred in the painting, we collected additional data by a technique called microfade testing to determine whether specific colors in the painting are vulnerable to light. We are continually discussing our findings with each other and with the broader scholarly community, including conservation scientists, conservators, and art historians, to build a richer understanding of this painting and, through it, Van Gogh's process.